How are you? So we need to solve this exercise in here. So it's equilibrium of a particle. So the box weighs 550 pounds. Determine the force in each support cable. So you can convert this value in here, 550 pounds to newtons. So 1 pound equal to 4.45 newtons. So the result in here is going to be 2447.5 newtons. So for that, remember that the first step you need to write the free body diagram. That is this one in here, free body diagram. And then in here you are going to put in here the origin, so in the A. And then you need to calculate the tension in the cable C and the tension in the cable B, and you know the weight of the box. So the second step is to write the two equations. So in here the sum of the forces, the sum of the forces of the x-axis is gonna be so this component in here, so it's this one in here, we can draw that, and then another component in here, and in here the angle is only with respect of the right triangle 3 and 4, and this is a number 5. And then you can write in here TC, the tension in the cable C, times 4/5, that is the cosine of the angle, so 4/5, so the adjacent side over the hypotenuse, minus TB, cosine of the angle, that is 30 degrees, and that's equal to 0. And then in here you can clear the equation to find TC or TB. So for that, TC times 4/5, it's equals to TB cosine of 30 degrees. So TC it's equals to TB cosine 30 degrees over 4/5. And then you can write this part in the calculator. So cosine 30 degrees, and then over 4/5, something like that. So this is equals TC, it's equals to TB times 1.08. Okay, so that's one equation, so that's the first equation. And then the sum of the forces in the y-axis, it's gonna be the component in the y-axis, the tension in the cable C, so it's gonna be 3/5, and then plus TB, sine of the angle, so 30 degrees, and minus the weight in here of the object, that it's 2447.5 newtons, and that's equal to 0. So in here you can substitute the value of TC, that is this one in here, in this part, so in this step. So TC, so TB, it's equals to 1.08, so you only substitute the values, and then times 3/5, then plus TB sine of 30 degrees, and this is equals, it's gonna pass in the other side of the equation with a positive sign, so 2447.5 newtons. And then you can observe that this part of the equation, it's only with respect to the tension in the cable B. So 1.08 times 3/5, and so this part in here, this step, is gonna be 0.648, and then plus TB sine of 30 degrees, that is 0.5, so 0.5, and that's equals to 2447.5 newtons. And then you can group TB and TB, so 0.648 plus 0.5, So TB, it's equals times 0.1.148. So in here you can find the result of the tension in the cable B. So TB, it's equals to 0.5 over 1.148, so 2131.97 newtons. And then once you know the tension in the cable B, you can substitute that value in here to find the tension in the cable C. So TC, it's equals to TB times 1.08. So this is equals to 2131.97 newtons times 1.08. So TC, it's equals to times 1.08. So 2302.53 newtons. Okay, and that's all, guys. So you need to find the tension in the cable C and in the cable B. Okay, see you guys.